want me to come closer to the mic? Yeah, the chat box open. Okay, can you hear me? All right, great. I think you can hear me without the mic, but for the audience, they can't. All right, so today we had this plan. We are looking forward to the discussion of the tunnel. Everybody used it. One way, 1 week, sometime you want to cross that tunnel. And you're always looking on the side and seeing what is going on. How is this progress going? It looks like it's phenomenal to me, the way they build it. So we were interested in seeing how it affect our side of Norfolk. And the other cities, of course, but for Norfolk, we're looking at how it's going to affect us and the resources and the transportation and everything that goes into it. So we asked VDOT and some qualified gentlemen over here, and they're going to give us a discussion. Open forum. If you have a question in the audience, just raise your hand, and we'll call on you. And right when it's fresh in your mind, we'll get those talks and questions covered. So I'd like to introduce Bradley. Bradley is with VDOT, and I will turn it over to you. Want me to do that? You want to do this? I just need to stand a little step back. Okay.
All right. Yep. Thanks for having us. Happy to be out to present on the project. Obviously, a lot of interest, and everyone sees what's going on out there. So I thought it'd be a good opportunity to explain what we're doing and where we're going. So we'll start with some quick introductions. Yeah, I'm Bradley White. I'm operations manager for VDOT. Been with VDOT for 21 years now. Since 2011, I started on the Midtown Tunnel project, worked there, and then moved on to this project. So, kind of traffic engineer by trade. It's a little wandering path to get to be a tunnel guy, which I wasn't expecting in my career, but it's been certainly interesting, and you'll see why here coming up. So I'll give the first part of the presentation, kind of the overview of the project and some of the progress. And then Chris will follow me on some of the tunnel.
Chris Foley, actually worked for a company called WSD, but serving as VDOT's engineering manager. Project, we got a team that's supporting VDOT with engineering support and construction oversight job. So kind of across all the different disciplines on helping few things that come in from the contractor into construction issues. Been in the area here for about 15 years. Most of the downtown tunnel projects. Done some tunnel inspections at one point in my career. So I've been actually all the tunnels in the state. But I've been on the HRBT project now for 2 years. And I'm so excited to talk to you guys today and fill you in on some of the details behind it.
Great.
If you could have that microphone going in and out, could you stand next to the podium there?
Sure.
Or if you like to walk around, you can carry that little microphone with you.
Okay.
That way people can hear.
Yep. I'll hang out here. Some off. I don't know. Feedback. All right. Hear me okay now?
You should be okay with that microphone right up close.
Okay, this one here. Oh, the little one, this one. Oh, I got you. All right, is that better? Okay. Button's not working. That's all right. I can do it from here. It's not working there either. Oh yeah, how'd you advance? Just the click it. Okay. The arrows go. Okay. Okay. All right. Okay. So I think everyone's familiar with the corridor. So I developed something called the Hampton Roads Lie Detector Test. Who has never been stuck in traffic agents? So you all passed. So yeah. So I mean, everyone knows the need for the project. Obviously, it's one of our major choke points in the region. the first tunnel was built in the 50s, the second one came online in the 70s, and since then traffic has just continued to grow. The areas continued to grow. So beyond just expanding the tunnel, looking at about a 10-mile corridor from Mallory and Hampton all the way up to almost 564 on the Norfolk side. This project will be part of a network that we have going on in the area, the Hampton Road Express lanes. So we're going to set a series of managed lanes from Jefferson up to Newport News all the way around 64 to Bowers Hill. So with that, we'll have always 2 free general purpose lanes, and also a series of whole managed lanes. So this is one piece of that project. So in addition to the tunnels, we are replacing a number of bridges, widening bridges, expanding facilities. So we're going to go from the current 2 lanes each direction again to 4 lanes each direction, 2 general purpose and 2 old lanes. So quick overview of the contract. We did award the contract in April 2019. It has a cost of $3.9 billion. It's a design build project, which if you're not familiar with the design build process, we select a team based on qualifications, technical requirements, and always kind of a combination of those elements. And once that contract is awarded, typically develop a plan up to 30% from there. We'll take on a fully finished design and construction. This project is just a design and build. It's great and maintain some of our other projects. This project that's a concession that's a long-term concession project. And this is not that. Once construction is done, it's time we'll be done with VDOT solely will in the facilities. The project funding is interesting in that HR TAC funded 92% of this project. If you're not familiar with HR TAC, 1% of our sales tax goes specifically towards transportation projects that fund. So our larger projects in the express lanes, widening in 64 up on the peninsula, high rise, those 6 projects are all funded through HR tax. That's where most of our funding comes from through local money, only 8% from state and federal funds. So it's really unique for a project of this size. Project partners, again, VDOT is the owner of the project. We will continue to own the facility during construction, after construction. HR Tax, our funding partner. And then our design build partner is Hampton Roads Capital Partners, we call it HRCP. That's a joint venture made up of Flatiron, Chicago, Stinksy, Golden Campion, and some worldwide expertise in tunneling and these types of projects. Also on their team, there's a joint venture of designers, Mike McDonald and HDR. So those are the primary players in this project. So as far as what makes it unique, we have a lot of firms on this project. For VDOT, it's our first Boyd tunnel. If you're not familiar with all of our other tunnels in there, they were built using immersed tube tunnels where you fabricate the sections on land, trench out the channel, immerse them down, and connect them. So really all of our tunnels here, downtown, modern Merrimack, the original Midtown were built that way, even the new Midtown tunnel was built that way. So part of this design build process, we put this out to industry. We did have options for either immersed tunnel or Boyd tunnel, and through that process, the Boyd tunnel did become the selective alternative. So we have the second largest tunnel in America. Seattle, they have a double decker tunnel and Boyd tunnel in the States, beyond Seattle. This clicker not. I did clicker. I put it in my pocket. Oh, you're good. All right. So one of the benefits of using the Boyd tunnel is that there are no impacts to the navigable waterway. Obviously, our channel out here is a very active channel. We've got the deepest channel to the port on the East Coast, the largest Navy base in the world. So a lot of stakeholders there use the channel by mooring. We're completely under the waterway, very minimal impacts. Also limits impacts build the tunnel, the oil going up and are coming by water, which limits the amount of truck traffic. And limited impacts by adverse weather. So you continue those operations 24/7. So our TBM tunnel boring machine has a name. But the naming rights out to some of the local schools. So this is actually a name from one of the schools. So named after Jackson, the NASA engineer in the movie. So some local ties there. You can see the machine, the colors of the cutter head, and the Hampton Roads flag. If you didn't know, we do have a Hampton Roads flag. Stars make up our calories, blue and the green, and the land and the sea. So you can see some of the stats on the TBM itself. It's really a massive machine. It was built in Germany by Heron Connect, the company that builds most of the TBMs worldwide. So that picture was actually in commissioned, and it was disassembled, sent down here to Hampton Roads and reassembled and use.
Hey, Bradley, I got a question.
Yep.
I'll ask for everybody in the room. You say the tunnel is 173 feet below surface level. So how far deep do the cargo ships and the big ships travel? Because I'm always in the tunnel looking up as like, how deep are these heavy ships going across me?
Yeah.
How far do they go down in the tunnel?
Yeah,
I mean,
here's a pretty good idea of that. So the existing tunnels are at 117. The existing channel depth is 72 feet. So the draft of those.
Sorry.
No, it's okay.
Mic issues.
That's okay. So the draft of those large ships is less than 72 feet, but if you assume they're almost to the bottom of the channel, we got a little bit of clean line to the existing tunnels. Yep. So quick, crash course in how TBMs work. It's really based on introducing slurry, which is a mixture of bentonite and water, to the cutter head. The cutter head is a piece that spins around. Creates a filter cake in front of the machine that allows us to that soil back through the machine and spot back out the other end. It's a slurry treatment plant that recycles the slurry, pulls out the excavated material, and sends slurry back into the tunnel. You can get a little bit of an idea of how the machine, those the two hydraulics point for the benefit of the people in the room. So these hydraulics can extend and extract. So we build each segment is a ring, or each ring is built up of 9 segments. So once a ring is put in place, the machine actually pushes off the segment behind it, retracts, builds another ring, pushes off, retracts, builds another ring. So that's how the machine advances, by pushing off the rings that it's building behind it. Again, this shows kind of relative to the existing tunnels where the new tunnels are. You can see this slight curvature away from the existing tunnels. That was to minimize any type of disruption or damage to the existing facilities. And you can see the depth. The new tunnels will be a 5% grade to get down to as quickly as possible to some better materials, supports, or some more compressed materials.
Apparently, when you're standing next to the podium, the mic isn't working. They said they can hear you clearly when you're standing here.
Okay.
Would you mind?
I'll stay here. No, all good. So looking a little bit at what the tunnel will look like on the inside, and Chris will get into some more of the details of some of the finer elements. But one thing you'll notice is that, previously when we do an immersed tunnel, we basically build a big rectangle to put traffic in. A rectangle is a pretty good shape to fit, a traffic envelope of lanes with height. The circle is not the greatest shape to put traffic in. So see, almost the whole bottom third of that tube is filled with ballast material and fill to get up to the actual roadway grade, to get the width of our 2 lanes through there. The new tunnels will have, you can see on the left here, an egress corridor. So in the event of any type of emergency, you can go out a series of doors into the egress corridor that gets you back to the portals for safety. So that is similar to the new Midtown Tunnel, if you've been through there, but we'll have that in the new tunnel. So a little bit of progress to date. Again, this kind of will summarize what you've been seeing out there if you've driven through the corridor. Starting up on the Hampton side, one thing on this project is pictures aren't current for very long. We did do a major shift in the last month. This is the Mallory Street Bridge. We did move traffic onto the new half of the bridge that you can see there to allow us to demolish the other half of the bridge. That bridge is getting fully replaced as part of the project. So from there, we get onto the new North Trestle. So earlier this year, we did open the new North Trestle eastbound traffic, which you can see here on the right. The reason to get traffic there so that we can demolish the existing structure you can see on the bottom. We couldn't quite finish it because the new bridge is in the way. So with that traffic shifted, we can now complete that bridge. You can see the kind of the stats there on just the amount of piles and caps and girders that we had to put in, but it's a pretty impressive structure if you've driven by it. A little bit on what the traffic will look like in the final configuration. Again, on the right is eastbound going into the new tunnels. On the left is westbound traffic. So you'll see the existing westbound tunnel on the far left remains the westbound tunnel. The existing eastbound tunnel in the middle there is around to become the second westbound tunnel. So again, the new tunnels will be fully eastbound. The existing tunnels will be flipped to westbound. You can see some of the traffic numbers here. The existing year traffic that we started with, 83,000, that's an average. During the summer, we hit the 90s, almost to 100,000 certain days. But with our traffic projections, you can see we expect that to grow up to 133. So certainly capacity improvement that's needed. We all see that. Looking at the North Island, and the North Island is on the Hampton side of the tunnel. We did have to expand that island. We more than doubled the existing island to accommodate the new tunnel landing on that side. So after we expanded the island, we built the slurry walls and the pit that we'll see here in a little bit that'll accept that new tunnel and turn it around. The South Island, this is on the side. This is really the home base for a lot of the tunneling operations. Kind of the bottom right corner there is our slurry treatment plant. Again, that's what processes all of the spoils coming out of the tunnel. Just given its size, it's hard to see in this picture, but it is a massive facility. It wasn't feasible to after the first bore move this over to the North Island. So this will be the center for all the tunneling operations for both bores. So as the tunneling comes back towards Norfolk, all the spoils will continue to come to this location. A little bit more of a close-up of the South Island pit. Again, all the tunneling operations will remain here, and we are starting to put some definable features in that pit now. So while the left side of that is the head wall where the tunnel bored through, really the right side of that picture is where you'll see daylight when you come out of the tunnel when it's fully constructed. So everything above that pit will become the support buildings for that tunnel. So you can see that dividing wall in the middle there that separates the two eastbound, the general purpose lanes and the hot lanes. Everything else in there will be a series of pump rooms, electrical rooms, just all the pieces that it takes to run the tunnel. So again, this is the South Trestle on the Norfolk side. That line in the middle, you can almost picture that as a cut line where above is the existing and the bottom is the proposed. So the existing trestles at the top completely get demolished. We're building the existing trestle off to the side, which you can see here. If you've driven by it, you probably notice it's significantly taller than the existing tunnel or existing bridges. Couple of reasons: resiliency, projected sea level rise, and also just to get it out of the splash zone there. Salt is sort of the end of bridges, so get it up higher so we get less salt on our bridge elements. So we are expecting to move traffic onto that structure in spring of 2025. So a lot of work happening there, and we are getting close to that first shift. Again, you can see towards the bottom, we aren't able to complete the full structure because we're bound by the existing. So we need to get traffic onto the new to be able to start to demolish the existing ones and complete those structures. This is kind of a close-up closer to the islands. On the left side there, you can see we did build a temporary trestle, that little bypass to put traffic on so that we could demolish the existing piece. On the right, you can see the temporary trestle that we will be moving traffic onto later this year. And again, once we get traffic there, we can demolish the existing to be able to complete the permanent tie-ins to the tunnels. Landside progress, really a lot of the work there is just the widening activities. All the bridges need to be widened, Willoughby Bridge being the longest. We also have a lot of shorter bridges in the corridor. We are rehabilitating all the bridges as well, in addition to widening. So we're doing a lot of work on the beams and decks and different elements that when this project is done, we'll be able to just be doing routine maintenance for the foreseeable future. Did want to highlight some of our maintenance of traffic and incident management, some of the considerations that we put in. So during construction here, we will be maintaining 2 lanes at all times, the 2 lanes that were existing. Obviously, lane closures are a part of the work, but those are limited to allowable lane closure hours that we have defined in the contract. So they're generally nighttime. It's a full matrix of allowable times depending day of the week, depending summer, non-summer. So they are limited to those less travel times for doing lane closures. We do put out a weekly advisory. If you're not familiar, you can get on our mailing list and check our website for those weekly advisories of when we're doing lane closure. We do have, as far as emergency management, there's an existing hurricane crossover just west of Fourth View. So there's a provision in the contract that maintains that crossover throughout construction. So with very limited notice, they would be able to make that passable so we could use it for any type of reversal that we do in the region. The contractor does have a dedicated incident management coordinator, so they are on site full time. So any minor incidents or major incidents, we can respond quickly. Part of that, they do have a requirement that there's a wrecker stage in the corridor full time, so that we can again quickly respond to incidents and clear. With the work zone, most of it is barrier on both sides. There really is limited places to get by. So the quicker we can clear those incidents, the quicker we can get traffic moving. And then we also do utilize VSP for work zone support. So you probably see them out in our work zones most days, trying to keep people slowed down and focused on the task of driving. Getting into the tunnel work, here you can see this is the South Islands. This is before we started boring operations, just before we started boring operations. The TBM setup on the left side in the tunnel is the cutter head. That's the piece that leads the boring. Behind it are 3 of the trailing gantries, and then just below the back end is the 4th gantry. So we actually had to advance the machine to even fit the 4th gantry onto the machine as it continued through. Towards the bottom of the picture is our quay for the tunnel segments. So all the tunnel segments were fabricated in Cape Charles and barged down to the site. This is where they're loaded up. And then that large gantry at the bottom lifts them down into the pit where they're delivered down to the cutter head. One other thing I'll mention here, there is a joint agreement between City of Hampton and City of Norfolk Fire. They are our tunnel rescue team. So in the event we would have either a major injury or fire down in the tunnel as it's being constructed, we have purchased special equipment for them to respond to that unique scenario. We've done a series of trainings with them. So I think that's a good news story of collaboration regionally and with the project. And really those teams are out on a monthly basis, just looking at the site. Things are changing out there almost daily. So they're always keeping situational awareness of what the active construction site looks like in the event there would be any type of incident or any type of rescue required. So the first tunnel we bored that we launched from the South Island was the hot tunnel, the high occupancy toll lane tunnel. You can see some of the stats there, but almost 8,000 feet, 1,191 rings. Again, every ring is made up of 9 of those tunnel segments. The photo on the right is our ring erector. There's a large vacuum that actually picks up the pieces and spins it around, puts it in place as we bolt it. And you can see the hydraulics there that we push off of those ring segments to advance the tunnel. So after we got 7,941 feet, it took almost a year to get there. You can see some of the rates of our best days of 17 rings, almost just over 100 feet in our best weeks. So, you know, this is a big system of sending materials back to the South Island to get treated, delivering the segments. So, you know, no one process can get ahead of the other. It's sort of a balance of moving and treating materials. So you may or may not have seen this video, but earlier this year we did complete the first tunnel. So it's documented. It's pretty cool, right? That's something you get to see every day. First time I've seen it personally. First time we've done it here in Virginia. So again, this officially made us our first bored tunnel in Virginia. Bay Bridge Tunnel is currently boring, but we did complete first, so we get to always say we were the first one to break through. So now that we are through, we got to turn around and go back the other way. So one of the bigger challenges on the project was figuring out the logistics of doing that. You can see our cutter head's 2,500 tons. So we couldn't really use cranes to pick it up and move it around. So the contractor utilized a method that's been used in Europe, not to this scale. This is really the largest scale that's ever been done. But underneath the cutter head is what we call a nitrogen skate. So they sent basically compressed nitrogen air in there. On the very bottom are some rubber bladders. The bottom of the floor was lined with steel plates that they put lubricant on. So by introducing that compressed air, it reduced the friction. They were able to use those pulleys and actually pull it around the floor back into place. So we have a time lapse of that. So this actually all took place within an 8-hour shift. So you imagine 2,500 tons. They just started pulling it around on that skate. So the best way I can describe it is when you're moving furniture, you kind of put the pads underneath and slide it around, kind of mix with an air hockey table of the air kind of just reducing that friction. So that's how they turned it around. So that happened just a bit ago. Actually, since then, the first gantry has been pulled out, turned around. The second gantry actually just came out this morning. They lifted it up top. They're going to turn it around and set it back down. So again, we have 4 gantries to turn around, and then sometime around October this year, we anticipate boring again to head back to the South Island. So that's the progress of tunneling. Looking at a couple just unique things that probably weren't as expected on the project. Here's a picture of just 3 barges in the background. We'll get to why I'm showing a picture of 3 barges. So with really any federal state project, we do have civil rights goals. So they're always usually based on a percentage of a contract. When you have a contract this large, those numbers just get very big. But I'm proud to say that we are meeting all of our goals on the civil rights side. Environmental challenges, that was a big risk going into this project. If you haven't heard, the South Island, which again was only built in the 50s, became home to the largest colony of colonial nesting birds in the world. That's just where they decided to migrate. So it's some terns and gulls and different protected species, but that was their home during bird season, which is about April to September of every year. So anytime they would lay an egg, we would have to create an exclusion zone, and really it would have impacted the project in a great way. So working with some of the agencies, we used the adjacent Fort Wool and those barges that we showed in the other picture to have a replacement habitat for them. And one way we encourage them to use it is through the use of the dogs. These are our border collies, kind of our unofficial mascots on the project. So similar to what airports do or golf courses, they really just scare the birds to go other places, and they did use those other facilities to find their new home. If you drive out there today, look over to the right, you'll just see a flock of birds flying around. So they really are the birds that made their new home over on Fort Wool. So that was a big good news story for the project. We were able to accommodate those and still move on with traffic. So we've had with construction. So we've really had very little impacts during construction based on the birds. Marine noise impacts protected species. So with driving all the piles in the water, there are restrictions on how we can impact the marine mammals and other aquatic wildlife. So as we're driving piles, we use bubble curtains, literally put bubbles in the water just to kind of restrict the amount of noise that propagates out into the water. So there's a couple of some of the unique things that we've done to overcome some of the environmental challenges and permit compliance things on the project. Some historic artifacts we found. So as we know, we are in the middle of where the Civil War occurred. So we in the process of excavating the pits on the island, we did encounter several cannonballs. So because the island was built using a lot of dredge material from the channel, this is probably their second home. They were placed here during the construction. We just happened to find them. So every time we do find the cannonball, we do have to reach out to the unexplored ordnance folks and come out and take a look at them. So we are opening up next month a visitor center off Fourth View. It's really the old Norfolk Visitor Center, if you're familiar with the location. 2 of those cannonballs are in our visitor center for people to look at. The other ones actually were explosive and were detonated by the teams offsite. So kind of interesting fact there. Also, as we were dredging for the North Island expansion, we came across these timbers, which everyone knew looked a little unique. So William and Mary actually did a full study on these, an archaeological study, and determined that they were from a shipwreck back in 1819. Based on the material around it, it was actually quarried stone from pretty far up the Chesapeake Bay, but matched the stone at Fort Monroe. So it was a ship that was delivering materials to the construction of Fort Monroe. But if you're interested, again, the William and Mary study, you can look up. It's a pretty interesting one. And then the one that really nobody had on the bingo card, but during the process of excavating materials, all the material comes out on a conveyor. There's some magnets that pull out any metal debris, and people are just looking at it for any abnormality to make sure we're not boring through anything that potentially damaged the machine. But someone did take note of some pieces coming out that, working with our Virginia Living Museum, determined that they were mastodon bones from about 50,000 years ago. So these were found under the surface. So these kind of just demonstrate that this was coastal plains back a long time ago. This is the furthest east we found any bones of this type. And again, those are on display at our visitor center. So we hope one day people can come out and take a look at those. But that's probably one of the more interesting things that we found through tunneling, and probably most unexpected. So before we move on to Chris to talk about some of the specific safety elements of the tunnel, I guess I'll pause if there's any questions from the room or online, or any of the progress, anything you're seeing out there that you might have questions on. All right. Okay. Yep. If not, we'll move on to Chris, and we can certainly circle back at the end for any final questions.
Thanks, Bradley. And before I get started, I'll say it. I did get the chance to be down in the shaft and see the breakthrough happening in person and the TBM U-turn. And the scale of these things is really hard to convey in these pictures. But it's taller than a 4-story building. So when you're standing right next to it, it's really just a massive machine. It's really neat to get to see this stuff up close.
I do have one question. Just
Sure.
They asked, what's the drill's nickname?
The name is Mary, the TBM that we went through before. I'm not sure if that's what they were asking, but
Mary.
yep,
Sounds
Mary
good.
after Mary Jackson, the NASA engineer.
Thank you.
So I'm going to dive in a little bit to the design of the fire life safety systems in the tunnel and some of the considerations that went into that. Tunnel safety standards have come a long way since the original tunnel was built. And this tunnel really does have state-of-the-art safety systems, many of which are not found in all the existing tunnels that we have. Probably the closest other tunnel that we have to this one is the Midtown Tunnel that was built, open to traffic in 2016, 2017. But even this has some additional things since then that have become part of the safety standards. NFPA 502 is the primary standard that governs the design of the tunnel when it comes to fire life safety requirements. So it's got all of the requirements in there for how to ventilate the tunnel, provide emergency lighting, egress, all those kinds of things. But we actually had some stringent project technical requirements that became part of our contract that had a lot of more specifics on what the contractor had to do with as it relates to tunnel safety. So we had specific requirements for the structure, as well as the mechanical electrical systems, the communication systems, as well as coordination, first responders and other stakeholders, and VDOT operations who would actually be using these systems in the event of an emergency. So we got a very detailed set of technical requirements that they had to follow. And part of my role as the engineering manager was, looking at the design packages as they come in and making sure that that they're complying with that and addressing everything that's needed in the design. So we'll just kind of touch on some of those subjects, and feel free to interrupt if you got questions. One unique part of this job is the project actually formed its own fire life safety committee. It was a requirement of our contract, and it involved the stakeholders here that you see on the screen, the local first responders, as well as VDOT operations, Department of Emergency Management, State Fire Marshal's Office. And so this was a group that actually was formed and came together throughout the design of the tunnel. So starting very early on in the process with regular meetings to review how the design was coming together, making sure that all the pieces and parts that we're seeing with the design were what we really needed in terms of operations, maintenance, and that sort of thing. One requirement that we have in the contract is for the design builder to develop an emergency response plan at the before the tunnel is open to traffic, and has not been done yet, but it's a key aspect of this job that will involve this fire life safety committee. So thus far, we've had, I think, 7 meetings over the last few years to review the different parts of the design. Most of the design is now complete. There's a couple of packages still outstanding, but the next, kind of major milestone is once we actually get the built and we get it commissioned and tested, we're gonna have to develop this emergency response plan and coordinate with all of the first responders and make sure that we've got a comprehensive plan to actually how these systems will get used and how people will access incidents in the tunnel and things like that. So these are some of the features that the new tunnels will have. On the right is a cross section just kind of showing the general areas of the tunnel. The blue shaded shape is the tunnel roadway area where the traffic will be. Overhead, you can see in yellow, those are the jet fans. These are axial fans that provide longitudinal ventilation through the tunnel, similar to what you see now in the Midtown and downtown tunnels. On the left-hand side, kind of shaded there in pink, is a pressurized egress corridor. Most of the existing tunnels around here, there's really, if there's an incident, there's really only one way out to go back in the way that you came. But here we will actually have this egress corridor that's continuous, running the full length of each tunnel. And it's got its own ventilation system that pressurized with fresh air. And there's doors throughout that will allow people to get into that corridor and escape if there were to be a fire in the tunnel. We've also got a fire protection system consisting of a combined standpipe deluge system, and we'll talk about that a little bit. And of course, we have fire detection systems, emergency communications. We'll talk about traffic control, as well as the drainage and the flood protection that we have in the event of a coastal storm. So starting with the structural fire protection, the latest edition of NFPA 502 requires us to protect the structure itself from fire to prevent damage to the structure and alleviate the risk of having a structural collapse due to fire. And that's based on several incidents that have occurred at major tunnels throughout the world. But the way that we do that here at this tunnel is with passive fire protection board. And it's essentially an insulation board that gets bolted to the surface, the concrete surface of the tunnel line, as well as the interior wall there. And it prevents the structural damage during the exposure to the fire. And the goal of that is to keep the surface of the concrete the surface of the concrete, as well as the reinforcement, less than 482 degrees. So the contractor designed this board. They had a finite element analysis that showed how this was going to perform. And they're actually now in the process of developing their testing plan. We do have a requirement they have to actually do a scale test where they expose the actual boards on a test segment and expose it to the fire event and make sure that it actually performs the way that we want it to during the design. So that's actually coming up here soon. We've got some testing scheduled here in the next couple of months. The pictures there you can see on the right is what this will look like. In some ways, that's got the fire protection board that is on the ceiling part of the tunnel and then tile below it. We have a similar arrangement. Our coloring will be a little bit different, but the same basic idea. It just provides that surface protection for the concrete. Emergency ventilation is very important in tunnels, particularly longer tunnels like this one. Portal to portal, we're roughly 8,500 feet because the board tunnel actually has a section of cut and cover tunnel on each side as you go through the approach structures. But the jet fans are mounted overhead. We've got 12 banks of jet fans in each tunnel, 2 fans in each bank, so 24 jet fans in each tunnel. And basically what these allow us to do is to move air longitudinally through the tunnel. And in the event of a fire with traffic stopped behind the fire site, we can push that air downstream where traffic is cleared out and keep that smoke and heat from backlayering over traffic. The fans are also fully reversible. So if we need to, for some reason, we can actually reverse them and send the smoke the other way once people are evacuated. The egress corridor, as I've mentioned, has got its own pressurization system. So there are ventilation fans located in the tunnel buildings on the islands that pressurize that. But then there are also booster fans, as you can see in the cross section there, mounted on the ceiling of the egress corridor. And those provide additional pressure throughout. There are pressure relief dampers and sensors that make sure that we're maintaining the right amount of pressure. And it's a kind of a balancing act between making sure that we're providing enough pressure to keep smoke out of that corridor when somebody's opening the door, but not so much pressure that we make the doors difficult to open. We also have a fire protection system. It's a combined standpipe and deluge system. So there's a wet fire main running in the egress corridor throughout the length of each tunnel. That is actually fed by 120,000 gallon water tanks located on each island. And then we've got fire pumps in each building. We've actually got 2 pumps in each building. So we've got extra redundancy. We've essentially got any one of those pumps can run the entire system. So we've got double redundancy. So from that wet pipe, you have hose valves that go to the cabinets along the roadway that firefighters can hook up, their hose to those valves. But we also have deluge valves that connect it to dry piping over top of the tunnel roadway. And that's what you see in the top right picture. There's sort of that red piping. There are zones about 80 foot long throughout the tunnel, and those have open sprinkler heads. And so when a fire is detected in a particular zone, that deluge valve opens, sends the water to that dry piping, and you have, sprinklers to suppress the fire in that area. For fire detection, we have a couple of different ways that fires can be detected in the tunnel. First off, we have the CCTV cameras. We have 100% coverage throughout the new tunnels. Those feed back to the control room where VDOT operations are constantly monitoring the flow of traffic 24 hours a day in the tunnel and can respond to incidents. We also have manual fire alarm pull stations like you'd see in a building located in the tunnel in the egress corridor. And then we have linear heat detection along the tunnel roadway. And so that's actually a wire loop that runs the length of the tunnel. And when it reaches a certain temperature, it can actually tell where along that wire the fire is located and will trigger a response. And so that's tied into some of the other systems like the deluge system and the ventilation system. And we'll talk about how those kind of come together. And then we've also got heat detection in the egress corridor, and then, the more typical heat detectors and smoke detectors in the buildings themselves. Talked a little bit about emergency egress, but this was an important part of the design that was challenging to accommodate. We have 13 sliding egress doors throughout the tunnel, and it's similar to what you see at the Midtown Tunnel. And there's, signage directing people with that green running man symbol that's become adopted for emergency egress. But the designer actually had to do quite a bit of modeling of various scenarios in the tunnel with fires to make sure that the door spacing was correct and that it looked at the maximum queuing of people trying to evacuate. So that was kind of done hand in hand with the analysis of the fire protection system and the ventilation system, because you're trying to make sure that you provide a tenable environment in the tunnel for as long as it takes to get everybody out through the egress corridor, because that fire is growing over time. And so, the ventilation system's keeping the smoke off of traffic behind the fire. The deluge system is suppressing the growth of the fire, and make sure that we can do that for a sufficient length of time so that everyone can get out of the tunnel safely. We have egress signs throughout the tunnel that'll tell people the distance to the nearest exit. We've got emergency lighting. And these corridors, essentially, they run the full length of the tunnel, and then they connect to a point of safety at the tunnel approach structures. They connect to there's an area of refuge, and then a stairway that leads up to the building that puts you out at grade on the islands. We also have several emergency communication systems in the tunnel. We've got the AM/FM rebroadcast system, similar to what the existing tunnels have, where VDOT has the ability to override the AM/FM broadcast in the tunnel if drivers have their radio on, and we can provide emergency messages that way. We also have a mass notification system with loudspeakers in the tunnel, so we can provide emergency messages to motorists. Call boxes with emergency telephones throughout the tunnel. We have two-way radio system coverage throughout the tunnel and the facilities. And then we've also got some requirements in our contract with provisions for installation of the STARS system by Virginia State Police.
Not be able to connect through that radio system, right, to broadcast the emergency message.
I believe that's correct. That is just AM/FM override. Yep. So NPA tells us that we have to have a way of stopping traffic from entering the tunnel in the event of an emergency, as well as clearing traffic downstream from an incident. So what we have is a combination of traffic control signals and message boards outside the tunnel on the approaches, with one right before each portal as you're going into the tunnel, similar to what we have today. That allows us to quickly stop traffic. If there's an incident detected, VDOT can do a full stop. There are also lane use signals throughout the tunnel, displaying either a green arrow or red X, like you see in some of these pictures here, that will be in the tunnel. There's also dynamic message signs in the tunnel. We've got vehicle detectors throughout the tunnel that allow VDOT to understand what's happening in terms of vehicle presence and queuing inside the tunnel and things like that. That's all going back to the control room. Yes. Yeah, that's just an example from a different project, but that's a dynamic message sign. It can be changed with different messages depending on what the incident is. Yep. So drainage, doesn't maybe seem like a fire life safety system so much, but it actually is a requirement of NFPA 502. Probably the controlling situation for the drainage system in the tunnel is dealing with all of the water coming from the fire protection system. We have drains that intercept water falling outside the tunnel, keeping it from going into the tunnel itself. But as you can imagine, when we made a couple of these deluge zones that are 80 feet long. We've got a huge volume of water to deal with. So that basically all flows down to the low point in the tunnel. There are inlets spaced throughout the roadway. And you can see the low point at the tunnel is not really in the middle. It's kind of closer to the North Island there. And that has a pump station. Pump station cutaway is kind of shown in the top right there. But we've got multiple submersible drainage pumps that can pump that water out, and it pumps it to a pump station at the portal. And that pump station then discharges it out to the bay. We also have floodgates at the portals. Similar concept to what we have at the existing tunnel. But essentially when we have a elevated water forecast from a coastal storm, we can lower these floodgates right at the portal and block off the tunnel in case the walls, the approach structure were overtopped with water. So that's designed to hold back water and fill up that entire approach section of the tunnel until the storm is passed. It can be pumped out, and it basically protects everything that's in the tunnel from being submerged. So I think you guys are probably familiar with what happened at Midtown Tunnel during Hurricane Isabel, and these floodgates are designed to prevent that type of thing from happening. And these are regularly exercised by VDOT. You probably see the messages a couple of times a year when these things are actually tested and exercised in the middle of the night by VDOT, and this will be the same.
About your emergency power backup system, especially communications, control room, signs, etc.
Sure. So emergency power is a big part of the design, making sure that we've got redundancy. So here we have two sources of utility power coming into the tunnel, but we also have large generators on the islands that are capable of supporting all of the emergency systems. So in the event of a power outage, typically if we lose one side, we can reroute power from the other side. But if we lost both utility sources, which can happen during a big storm event, we have generators that can provide the backup for the entire facility. Sure. Yeah, we might talk about that here when we get to the SCADA system. So the SCADA system stands for Supervisory Control and Data Acquisition, kind of a mouthful, but it's essentially the brain that talks to all these different systems and integrates them together so that you can have a unified response between all these various systems acting together to create a safe situation. So the picture on the right there is an example of a video wall in a traffic operations center. We will have a similar type of arrangement here for the new tunnel. So there will be a primary control room where VDOT staff have the ability to monitor, operate, control all of the new tunnel systems as well as the existing tunnel systems. Then we will also have a secondary control room in the event of an emergency that required evacuation of the primary control room. We have full capability to do all those same things at a secondary control room with a similar style of video wall and workstation. Everyone. One of the things that the SCADA system does is helps to minimize operator error. So there are a lot of pre-programmed emergency modes. Typically they still have the ability for the operator to intervene, override as necessary, but there are a lot of pre-programmed modes where based on a fire at a certain location, it will allow a specific response from the ventilation system and the fire protection system. So, if the linear heat detection system says you've got a fire near the middle of the tunnel, the ventilation fans will turn on to emergency mode, and the fans furthest away from the fire will start first to minimize disruption and backlayering of the smoke right near the fire. They will all eventually turn on, and then the deluge system will activate to suppress the fire. But all of this can be confirmed by the operators that are looking at the screen, looking at the cameras, and making sure that the system is doing what it's intended to do. So when it receives a signal that there's a fire, essentially starts a countdown, says it'll implement this sequence in this time unless the operator intervenes and does something differently. So I thought it would be useful to just kind of walk through what that actually looks like. This is a series of 3D graphics that was prepared by the tunnel designer. So during normal operation here, you've got traffic flowing through the tunnel. You can see the red pipe above the roadway is the fire protection system. The jet fans are sort of the white cylinders. So if we detect an incident, essentially a car stops and catches on fire in the tunnel. And smoke will start to, emerge from that fire. Depending on its location in the tunnel, that smoke may start to travel uphill, back over traffic. At this point is when the systems are actually detecting that, hey, there's an incident here. Many times VDOT will be able to see this on the cameras, know there's something going on before, we get to a situation where the linear heat detection system needs to be triggered. But once that happens, the emergency ventilation can be activated. And you can see now that smoke is all being pushed away from traffic stopped behind the fire. And that's the goal of that longitudinal ventilation system. People are now starting to evacuate through those green doors. That's where the sliding egress doors are, into the egress corridor, and be able to get out of the tunnel. And then here you have a combination of the tunnel ventilation system and the deluge system operating together to help suppress that fire. So really all this stuff needs to work together for it to improve safety. So a little bit about the progress that we've made. Bradley kind of showed you where we're at in the heavy civil construction side of the project. We're not quite there yet in terms of construction of all these systems. Once we get a little bit further along with the tunneling, we'll see these systems come online. So this being a design build project, the construction and design are happening simultaneously. They're able to stage parts of the design and construction to happen so that we're able to get out ahead of things with some of the heavy civil work. So the design for the tunnel fire life safety is really broken into a few different packages. We've got interior structures, the fire life safety package itself, which has the fire protection systems and the emergency ventilation, most of the mechanical systems. We've got the tunnel electrical power design, generators, the electrical feeders, all of those things. And then we've got the tunnel communication system with all the fiber in the tunnel, the emergency communication systems, the SCADA system. So all of those are kind of in these different design packages. We've now gotten through the interior structures and the fire life safety package. The design is complete. But we still got a couple of things pending to get the design finalized for the electrical and the communication systems, but we expect to have that finalized in the next couple of months. The last thing is the tunnel buildings. A lot of the systems are within the buildings that are located on the islands. We have what's called a ventilation building at each tunnel approach, but we also have a traffic operations center building on the North Island that has the primary control room space for VDOT to work in. So that final design is still pending as well. But again, here in the next few months, we're hopeful that all of that will actually be finalized. In terms of construction, Bradley mentioned the coordination that's been happening with first responders and the agreement with Hampton Fire Department. So these are some pictures of the planning and drills and exercises that have actually happened inside the tunnel. Those top two pictures there, you can see the tunnel segments in the background these exercises have been done between our design builder HRCP and the fire department. We're starting to see the procurement of tunnel systems. So, shop drawings and various vendors submitting their delegated designs. The commissioning testing plan is currently under development. That's going to be an important part for us as an owner, making sure that we have a well-established plan for ensuring that all these systems are tested and functioning properly. And then what I mentioned earlier is the emergency response plan. So that's still to be developed, and that will be another key milestone that we pull that Fire Life Safety Committee in back into the project to make sure that we've got that properly developed and coordinated. So that's really all I've got, but happy to answer any questions that you may have.
Nothing yet.
Okay. Well, if they chime in, we're happy to help.
Go on.
Need this.
Sure.
Hopefully I won't.
All right. Well, I want to thank you, Bradley.
Yeah.
Thank you, Bradley and Christopher,
Yeah, for having us.
for that. And as a token of our Christopher. Chris, sorry. Certificate, appreciate it. Fire department. Which is, this is fascinating. I found this great. As I said before, I had done a tour with the Chesapeake Tunnel, and it's amazing once you get inside the tunnel, all the different layers there are. As we drive through, we just see our cars, but on the inside, you can see all the electrical one panel layer. And then as you go higher and higher, you just see everything that's involved in that. And it's amazing how you keep everything, safe and from us. So thank you very much for everything you do. And we're looking forward to the finished product, and we'll be watching it. So anybody that knows where the Norfolk Visitor Center is, right off Fourth View, as you're coming back from Hampton, if you go in there, that'll be their new shop that we can see all the work they've done. So very good.
The hub. So if you have an easy pass, you can ride as a single user, pay the toll. If you got easy pass flex and you've got 2+, you can put it in flex mode and ride for free. Yep.
And that's just one tunnel.
One tunnel in each direction, yeah. One tunnel dedicated to high occupancy tolls, one tunnel is free GP. Yep.
Thank you. You can have a seat, or you can get your. We'll get your. I know. I know it's hot in here with the weather. We've got the doors open, so we'll go ahead and continue with the rest of our program. We're going to talk about roundtable and what's been happening with us in the last past month. I'll tell you, our office over in emergency management has been very busy planning and preparing. We've been watching the several storms that have passed by. We've crossed our fingers. Hold on, gentlemen. Hold on. No, that's not your one, right? You got it? Okay, I'm sorry. Thank you very much. So as we watched all the storms pass by, Burrell was the first one of the season. It looked pretty innocent. It was in the Caribbean and it came by and we were looking going under Florida, hitting Mexico. We thought everything was fine. And decided, hey, y'all aren't paying attention to me. Let me turn around. And it hit Texas and then went up to the United States. So we still have to keep alert on all these storms. We are monitoring Debbie as it came by and the storm and the waves that were hitting the Eastern Shore. And this last storm, Ernesto, we were watching that as well. So we're planning and watching out for everything that's coming around the bend from our office, and we'll keep you all abreast with our Norfolk alerts, with our constant meetings, calls, and everything that comes around. One thing I want to share with you it's been a week now, and we're all recovering. August 11th, it was a Sunday. We partnered with the Norfolk Police, Norfolk SWAT, Norfolk Fire Rescue, the State Police, the Jewish Security Council, and we had an active shooter drill at the OHEF Temple, Shalom Temple, and that went well. We tested the capabilities of what would happen with an active shooter, learned a lot of lessons on the way the SWAT team comes in, the police come in, the fire rescue came in and got rid of or took care of the hostages as well. So very, very good drill. We are constantly working on drills on Small John's talk, but we're still out there involved in the community. And just a reminder, hurricane season just started in June. And our area that we really have to watch out for is coming up now, between now and October. So we will be on alert. So anybody that does not have Norfolk alert, please sign up and get it for us. So we'll go around the room. Tracy, do you have anything? We're all good? Nothing. Red Cross, how about that? Y'all been busy.
Yes, we were busy because a couple of weeks ago, we went into the Norfolk neighborhood to pass out literature on excessive heat and how the residents can deal with it. And that was a first for the Red Cross, and I think that was successful.
Yeah, I want to thank you. You did 2 neighborhoods a couple weeks ago and then last Thursday. And I think you have 2 more neighborhoods lined up for the city of Norfolk, passing out those door flyers on heat exhaustion, heat safety. And thank you for the partnership with the city of Norfolk on those flyers that they're actually passing out at doors. It has the link to norfolk.gov/heat and some advice that we give out as well. So that's a great partnership with the Red Cross and the city of Norfolk. Thank you for that. All right, Mike, what's going on?
We had a blood drive at with the Red Cross at one of our water treatment plants for as part of the Mayor's Cup blood drive challenge. So that was a good turnout for that. And otherwise, we had a little bit of a storm drain repair that we had to do at our operations facility, but fixed it. It needed a repair after the fix. Got fixed again. Should be good to go now.
Good,
So,
good. All right, John, what do you have coming up?
Lots of things coming up. First, believe it or not, it's back to school time, and the health districts are all doing back to school vaccinations, trying to get the young people ready for return to school. Every year, there's a certain percentage that don't get the message and get turned away on the first day of school and have to come and line up at the health department to get their required vaccinations. But we're trying to get ahead of that. Also, flu season and planning for seasonal flu vaccine clinics, particularly exercise vaccines. So the Commonwealth provides us with a quantity of flu vaccine that is free to the public each year, with the promise that we each health department do an exercise. So I'm not sure exactly what Norfolk has planned. I don't know if Eve is on the call. Virginia Beach did their initial planning meeting for a drive-through clinic this morning. So that's one of the reasons I was on this side of the water. And the big thing in the world is planning for a cruise ship exercise with Coast Guard and CBP. You all from the city of Norfolk, particularly emergency management, the quarantine station at Dulles Airport, and myriad other folks, including the cruise ship industry. We're going to simulate a cruise ship showing up with a large number of ill or exposed individuals at the terminal, and then we're going to see exactly how we were going to manage that, what that unified command looks like, what the public information part looks like, how we communicate, maybe even talk through some high-level family assistance / reception, kind of how do we deal with people calling up wanting to know where Aunt Sadie is. Obviously, we're going to move some of these patients and simulate moving some of these patients into the hospitals to provide a surge exercise for the region's hospitals. And then the part of it that most people don't necessarily appreciate how complex it can be is the epidemiological investigation. So we're planning a 2-day tabletop exercise. The first half, is the kind of the run up to how do we get the information? How do we coordinate unified command? The second half of the day will be the public information and the beginning of the medical surge. How bad is bad? How do we triage these folks? We'll go home for the night, and a parallel group of people will come back for the second day, where we're moving, let's just say 1,000 worried, concerned folks into our healthcare system, and how we manage that. And then the second half of the day will be how do we follow up with those people as far as the epi investigations, what tools need to be done, how do we actually kind of get our heads around such a huge influx. So that is planned for the week, the Monday and Tuesday after Inauguration Day, downtown at full moon, although there's a little bit of a glitch in that. So maybe looking for another venue, but for now it's scheduled for the cruise ship terminal.
So we're looking at January for all that.
January, I don't have my calendar in front of me. The 23rd, 24th,
Yeah, usually,
into that effect. It's the weekend after Martin Luther King.
so it's going to be a carnival ship, going to be docked at their normal place over at Half Moon.
Yes,
Uh,
it's simulated, obviously, that there will be.
Yeah,
a-
and then that's where we have all the patients from.
Right.
Very good. I heard something, a rumor, and I'd hate to spread it, but
It's true.
okay. Is there anything that starts with COVID that's going around again? Is that an uptick or what? Are people getting it again? Because I know some people that have caught it recently, and I don't know if that's a big thing from the
Yeah.
health department looking at it or not.
So in simple John Cook terms, we are seeing an increase in influenza-like illness, respiratory illness, however you want to categorize it. You know, back during the dark ages of COVID, we were looking at dashboards with specific numbers of COVID cases that are being tested. We have transitioned away from that to respiratory illness is respiratory illness, and the number of folks that are showing up with respiratory illness, not otherwise specified, probably COVID, maybe flu, is on the upswing, and that is not a seasonal characteristic. So that is a little unusual, but it's not the coming of the next wave.
Okay. Well, thank you for update on the schools and getting those kids vaccinated to get to schools. It's and in Norfolk, we've already started this week. So the other cities are beginning next week as well, 26. So I think we're getting back in track on the fall. And I know for our office, we brought the cooler weather this week. We just didn't bring the AC to the building, but we brought the cooler weather outside. So we're
So Norfolk
doing.
schools have already started?
Norfolk school started Monday, the 19th.
I was not aware of.
So big push in that. Anyone else? Karen, you have anything? Mr. Hudson from our office.
The department is currently talking with Norfolk State University about what all foods got next. That's great. Pass along. Thank you so much.
I have no other questions. Thank you all for attending today. We'll have the notes on our blog and board for everything going on, and we'll keep the PowerPoint for anybody that might want to look at it and get some good information. But thank you all again for coming out. Have a good rest of the day.